This problem which we have is involving a lot of square roots, cube roots, fourth powers, fifth powers in the numerators and denominators, and we want to find the limit as our x tends to infinity. Now these type of problems in which there are a lot of square roots, cube roots, fourth powers, fifth powers involved, we have a set method and we try to learn that method. Now first of all, what we do is limit x tending to infinity, we check what is the highest degree of x inside the square root, cube roots, fourth powers, fifth powers, etc. which are involved. The highest is x square involved in this, so we bring this x square outside. This x square comes outside as x, and we see there is 1 plus 1 upon x square generated inside the square root. We try to generate terms like 1 upon x square, 1 upon x cube, 1 upon x power something, so that as x tends to infinity, this 1 upon x term goes to 0. So we try to generate these 1 upon x power m type terms everywhere in the problem. In order to generate these 1 upon x power something terms, we have to bring the degrees of x or the x terms outside so as to generate these type of terms. Now in the second under cube root, we have x square, x and 1, and the highest power of x is 2, so we bring this x square outside. It will come outside as x power 2 by 3, and what we get is, this is cube root 1 plus 1 upon x square plus 3 upon x. So we can clearly see that there are terms of 1 upon x square, 3 upon x getting generated inside the cube root. Here the highest power is 4, so we take x power 4 outside. It will come as x into fourth power of 1 plus 1 upon x power 4. Here also 1 upon x power 4 is getting generated. Here the high powers are 4, x power 0 and x power 2. The highest power is 4, so we take x power 4 outside, which will come out as x power 4 by 5 into cube root of into fifth power of 1 plus 1 upon x power 4 plus 3 upon x square. So now we have x into a bracket involving 1 upon x type of term minus x power 2 by 3 into some other cube root x power 4 or rather x into some other bracket or fourth power into x power 4 by 5 into something. Now we see the terms which are outside the square root, cube root, etc. They are x power 2 by 3, they are x and x power 4 by 5. Now we can't directly put x is equal to infinity because we know this term will get equal to 0, these terms will get equal to 0, this will get equal to 0 and this will get equal to 0, but there are terms of x power 2 by 3, x power 4 by 5 which will create a problem. So we can't directly put x equals infinity. For this we need to check what is the highest power of x involved in the numerators and denominators which are outside the square roots and cube roots. There is x whose power is 1, here is x whose power is 2 by 3, here is x whose power is 1, here is x whose power is 4 by 5. We see that the highest power of x is 1. So we divide the numerator and denominator by that x which is having the highest power. So we divide the numerator and denominator by x. This we do again in order to create terms like 1 upon x. So our question on dividing the numerator and denominator by x becomes limit x tending to 0, 1 plus 1 upon x square. On dividing this by x, we get 1 upon x power 1 by 3 into 1 plus 1 by x square plus 3 by x. This was x tending to infinity, and we have, this was actually cube root. On dividing the denominator by x, we get fourth power of 1 plus 1 upon x power 4, and on dividing this by x, we get 1 upon x power 1 by 5, fifth root of 1 plus 1 by x power 4 plus 3 by x square. Now we can see the whole question of ours has been converted into terms which are 1 upon x power a positive quantity. So we can very clearly now put x tending to infinity. On putting x tending to infinity, this becomes 0. This whole of the term becomes 0 because of this term. This term becomes 0 again, and this whole of this term becomes equal to 0 because of this term. So our final answer is 1 minus 0 upon 1 minus 0, which is equal to 1. So the thing which we learned from this question was, whenever we have problems like square roots, under roots, fourth powers, fifth powers, etc. in the numerators and denominators, and we have x tending to infinity type of question, then in these type of problems, either first of all we put x equals 1 by t, so that t will become equal to 0, but this would not make the question much simpler, because again we would have to have the same approach. The approach was, we tried to create terms like 1 upon x, 1 upon x square, 1 upon x cube, that is 1 upon x power m type of terms, so that we could very easily put x tending to infinity in order to clear out those terms. Here m was a positive quantity. This is the general and the most basic approach which we apply in these type of questions, and a final answer for this question is the limit equals to 1.